Good morning, team. We have received 4 samples for evidence from an illegal drug lab. So the first one, wall residues. Second, mysterious white powder. The third one, fibrous fabric. And the fourth one, unknown soil samples. So each of these might hold the truth. We have to break it down. Let's do it, team.
I handle everything with precise precision. I document everything with good condition, with complete of chain of custody. Cross-contamination? Not on my watch.
White powder? It could be flour or something more dangerous. Let's run it through the GCMS. Gas chromatography separates the compounds, while mass spectrometry identifies them by weight. The results, the exact same as cocaine. This isn't sugar, this is a drug operation.
So this is a diagram on how the GCMS works. So first, the sample is injected inside the water sampler, and the gas from the gas cylinder will travel through the regulator and through the tracks and will push the sample towards the column, and the column will then separate the sample based on their compounds. Once it is separated, it will travel towards the column oven through the transfer line inside the mass spectrometer, and which will then ionize the separated compounds into neutral charges, and then it will then be moved towards the computer data, which will then be read as a chromatogram.
The wall residues are stained and powdery. I use FTIR, a method that uses infrared light to detect chemical bonds. And as you can see, it matches ephedrine, which links to drug manufacturing. And this links the scene to illegal activity.
Okay, so how does FTIR work? So here is the example. First, we have the FTIR source, or the infrared emitted from the FTIR, which then come contact the against filter, which then separate some of the FTIR to a global mirror and a fixed mirror, which then come back to the beam filter and goes through the sample. When it goes through the sample, it goes to a detector, which then detect the FTIR substances. And then it makes an interferogram, which then the interferogram goes to the computer, making a graph or the spectrum, which the chemicals and substances vibrate accordingly. So by using the spectrum, we can form the residues in the sample and compare and analyze which residues can be found in the sample. For example, like math.
So these fabric fibers were found on site, so most probably from the suspect's clothing. So after running through SEM, scanning electron microscope, under a microscopic level, chemical residues are found on the surface. So this might indicate the suspects are present during the drug synthesis.
Okay, so how does the SEM work? First, we need to coat the sample with a very thin layer of metal, such as like gold, to make it very conductive. And then we put on the sample onto the slide of the SEM. So the SEM will focus a beam, electron beam, through the SEM and then to the sample, which then make a 3D like high resolution images that can be further analyzed. Usually the SEM are paired with EDS or energy dispersive X-ray spectroscopy, which then can identify the elemental composition of the sample.
So this is a corroded metal tool, also known as a rusted chisel, and for this one we found it near the crime scene, near a window which was broken, and we suspected that it has been used to break the window. And to analyze this tool, we will be using an X-ray fluorescent gun. So this is an XRF gun which we will be using for the crime scene analysis, and what it stands for is X-ray fluorescence. So this is a diagram on how the XRF works. First, it is bombarded with X-rays, and the inner shell electrons will then be knocked out from the atom inside the sample, and it will then cause the atom to become unstable. Once it becomes unstable, it will then emit fluorescent X-rays, which will be detected by the detector, and the detector will show them based on their energy levels and their intensities. So this is how it looks like, and this is an example of an X-ray fluorescent result. And as you can see, there are multiple peaks. So the highest peaks show that that is the element that is present inside the tool. So the results from the X-ray fluorescent graph can help us determine whether the rust was formed naturally, and it can link the tool towards a specific environment, such as whether it was found near seawater or exposed to fire.
So these are the soils that were found on the floor near the tools on the crime scene. So what do we use? We use the HPLC. What is HPLC? It's the high performance liquid chromatography. So how does it work? First, the sample liquid is pushed through the column at different speed, which then separate the substances in the soil at different speed. So the results are shown in the graph named chromatograph. So as you can see, there are two peaks. One is the drug peak and one is the waste peak from the same process. So the HPLC help us to see what's can be seen in the human eyes. So in conclusion, the white powder we use the GCMS. The results are shown the cocaine powder. So next is the wall residues. We use the FTIR that shown us there is ephedrine in the wall residues. Next is the fabric fibers. We use the SEM. It shows that chemical substances is in the fibers. Next is the soil. We use the HPLC. HPLC have us shown that there is cocaine substances in the soil.
All together, with science, teamwork, and precision,
We, as a forensic team, has cracked the case.
case closed!